And I'm going to use a different paper, but you can just use this worksheet to do the homework. Or if you want to just pause the video on this worksheet, you may do that. And for instance, sine of 120 degrees we said was about 0.87, so I just rounded that to the nearest tenth. Maybe the homework says, what's the sine of 100 degrees? Let's look at that one. So for this worksheet, every tick mark is 10 degrees. So if this is 90, then 100 degrees would be here. If I find the height of the graph right there, that's pretty close to 1. So round to the nearest tenth. If you want to use a calculator also, go ahead, but I want you to start by finding the height on the sine calculator or your sine graph before you go to an actual calculator and just type in the numbers, because I want you to have some understanding of the meaning of the numbers. I also want you to note that the sine, I draw a horizontal line, has two outputs, two heights that are exactly the same within this one rotation of the screamer ride. There's also, let's see, it's right about here, 2 times that the screamer ride equals that same height but with a negative number. So sine equals the same decimal 4 times, twice with positive decimals and twice with negative. Now before we end, we're going to graph the cosine function. And then again, the worksheet, or the practice that goes with this is just calculating these decimals. So one more graph. I want to go back to the screamer ride for a moment. What we calculated for the sine function is the height of each seat. For the cosine function, we will be calculating the base of this triangle. If the angle is located here, base is adjacent over hypotenuse, so it does make sense to use cosine to find this length. Please find your second worksheet, the one that has a y-axis that says base. We're going to name this worksheet, and let's just pause for a moment, make sure it says base here. If you printed the other one twice, you can always cross out the word height and put base there. Please name this the cosine function. This time, the input is your angle still, but the output now is the base side of the triangle. I've highlighted one triangle here and indicated that we're working with the side labeled base and side labeled radius. I've also called this side length the horizontal distance to the y-axis, or even to the origin. All right, cosine. For 15 degrees, I just use theta for the formula, but I'll switch to the angle here. Is the base side divided by the radius side. Remember, this is a unit circle, so the radius is 1 all the way around. So the radius is 1, and I use 15 degrees for the angle. Well, base divided by 1 is just base, so I went ahead and called that base. So if I just use my calculator and type cosine 15 degrees, I'll find this side length for every triangle that I could draw. Just write the decimals around the triangle like we did for the sine function. Before we continue, I will ask you one more time to pause, add the angles all the way around, and this time I did put the angles on the inside, and then put the decimals beside each angle that represent the length of the base of each triangle. You don't need to draw all the triangles. I just want to see angles and then the cosine answers all the way around. If you want to continue a little further before I continue, you'll plot then at 15 degrees, the height of the function will be the base length. Please pause and write angles and then the cosine values or base lengths of each triangle now. Okay, welcome back. Here is what I got. So you can see that I got positive base values here. And let's review again what 0.97 means. The base of 15-degree triangle is this side. So remember, from here to here is 1 unit, so 0.97 makes sense. This length is almost all the way to the edge of the circle. Whereas for the 75-degree angle, you're looking at this triangle. Notice that the base side is very short, so having a small decimal makes sense. And compare these decimals with the sine decimals, and you'll see all the decimals are the same. in the reverse order. I think I'll show that too. Look, 0.26, 0.5, 0.71, 0.87, and 0.97. All right, so we're going to take 15 degrees as our input on the x-axis and use our output as the cosine or the length of the base of the triangle as our output. So when you started on the right, you were exactly as far away from the center of the right as you could be. So you wouldn't even have a triangle, it'd just be a straight line to 1. So at 0 degrees, you plot 1. And then at 15 degrees, you plot 0.97 and continue. You could see I had plotted these and then erased them. At 90 degrees, you are on the y-axis, so there is no triangle. And if there was, it would have a 0 as the base. So you should get to the x-axis at 90 degrees. Please take a minute and pause the video last time and plot all the points that you get. And let's see what the cosine function looks like. All right. On this graph, you should get something that looks like this. Please note this is just one rotation of the ride. And so this graph can continue on just like sine would continue on. And if you compare the sine and cosine, they pretty much look the same. They just start at a different spot in that same like up and down sinusoidal curve, it's called. So notice that the graphs have a lot of similarity. So again, last thing, and we'll end our lesson, is that on the homework again, you start with just writing fractions of what sine equals and cosine equals based on triangles. And then you're asked, hey, what does cosine equal for? And then an angle will be given. So let's make up an angle. How about 160 degrees? That would be right here. Again, each of these lines goes by 10 degrees. So 160 would be right after 150. If I ask what the cosine of 160 degrees is, this is an example. I'm going to say approximately equal. I don't think I did that earlier, but just a reminder, you're giving an approximate answer. You go down to the graph, and you find that spot, and you approximate what that decimal is. So let's see, 0.5, 0.6, 0.7, 0.8, 0.9, so about 0.95. If you round to the nearest tenth, then you would say 0.9. It is a negative value, so don't forget to add that negative. If you want to round it, since you're in between 0.9 and 1, then maybe 0.9394. And as I mentioned for sine, if you want to use a calculator to see how close this is to what the calculator says, you can. But please compare the y values to this graph or the one you have on your paper first to see that connection to the graph. And that's the unit circle introduction. We will work with the unit circle much more in the lessons to come, as well as what the sine function and cosine function represent. Please now try the practice that goes with this lesson.